Good day. This is welcome to RGES Pre-Algebra, Lesson 28A. We're covering lesson or section 8.5 and 8.6 in your text. I wanted to begin with a brief verse from the scripture from Isaiah 30:15a. It says, "In returning and rest you shall be saved," or shall you be saved. In returning and rest. Okay, so this is obviously an opportunity for more rest and quiet, solitude, returning to Him. Okay, and so I would encourage you and exhort you just in this time where things have slowed down to, rather than being frenzied and worried and upset, as many people might be tempted to do, that you would plant yourself firmly in Him, return in Him, recognize that your hope is in Him, and rest in Him, knowing that you have a good Father. He is good all the time, and He is sovereign. So just rest content that He is on the throne. He knows what He's doing, and He promises to work all things together for good. So I wanted to encourage you in that. Please do take some extra time for prayer, both personal prayer, grounding your faith or stirring up your faith, but also for prayer for others, especially leaders, caregivers, and those that have already succumbed to, both physical duress with the contraction of the virus, but also with emotional duress as they're trying to care for loved ones, and also for financial duress and economic duress. So these are troubling times, but don't forget who is on the throne. In returning and rest, you shall be saved. Now we are in chapter 8, which is the subject is geometry. We have talked about many terms already, such as a point, a line segment, a ray, an angle, intersecting lines, parallel lines, and a plane. So if you cannot define those or understand the symbols that go with each of those, please review back to 8.1, vocabulary and symbols. Then we moved in to 8.2, and in that we talked about plane shapes. That means not plain, like not fancy, as opposed to fancy shapes. This means plane shapes, like they stay within a plane. To do that, we could say they're two-dimensional shapes. And so we talked about two-dimensional shapes. We talked about curves. We talked about closed curves. And we talked about simple closed curves. So this would be 2D, two-dimensional. We talked about how do we name simple closed curves based upon the number of lines they have. So we have the triangle for 3, for 4, you would have the quadrilateral. For 5, you'd have the pentagon. For 6, the hexagon. For 7, the heptagon. For 8, the octagon. For 9, the nonagon. And for 10, the decagon. I'm not sure I asked you to go up that much, maybe only through 8. We talked about special kinds of quadrilaterals. If you recall, we could have the rectangle. We could have the square. You should know these. We could have the parallelogram and the rhombus. And we could have the trapezoid, where we would have one set parallel, one set of lines parallel, but not the other set, something like that. All right. So that would be a review of 8.2. 8.3, we talked about measuring lines. We talked about perpendicular lines. This is parallel lines. like that. That's how we would symbolize it. By the way, I don't think I did talk about that. And perpendicular lines, which are lines that when they intersect to form 90 degrees. Okay. That's 90 degrees. I'll get it there eventually. All right. We talked about through a single point, you could have an infinite number of lines. Recall that? That makes sense to you? Okay. And that would be 8.3, and then 8.4. We talked about facts related to angles. So we discussed more about angles. We said that when you have an angle, this is called the vertex. And we have two rays extending from the vertex in that direction and that direction. And when we're going to refer to an angle, we could refer to it just by the vertex, or if this were A out here and B out here, we could also refer to it as AVB, where the vertex is in the middle, or angle BVA, where the vertex is also in the middle. So all three of those are legitimate ways to refer to an angle. And then we talked about all kinds of specific types of angles. We can name angles by the number of degrees. We talked about how anything less than 90 degrees would be an acute angle. At 90 degrees, it would be a right angle. Anything between 90 and 180 would be an obtuse angle. And this would be 180, and that would be a straight angle. And anything greater, whether it be this far or this far, doesn't matter, greater than 180 would be a reflex angle. Because why a reflex? Let's talk about that just a little bit more. Here's a reflex angle. And let's say it comes over here, and we've got to 95 degrees, let's say, all the way around here. We could have also measured it from this side, and it would only be, let's see if I can do that math, 65 degrees. You see how that works? So a reflexive angle is when we consider the part larger than 180, but its partner would be here. Okay, so we could have come from the other side and moved backwards from the initial point, and we would get a small angle, an acute angle. Okay, so the acute angle and the reflexive angle in this particular example represented by this ray right here and the baseline, okay, right here. We could talk about two angles. We could talk about the acute angle and the reflex angle, and together they would add up to how much, do you think? Well, if we went all the way around, how much would that be? Well, this is 90 in the first quadrant, and 90 more, right? 90 more, do you know how many? And 90 more, 4 times 90, or how many degrees are in a circle? 360 all the way around, okay? So those are just extra little ideas. Now, we talked about complementary angles. That means two angles that would add up together to give you 90. That would be angle A and angle B equal 90. We talked about supplementary angles. Angle A and angle B would add up to be 180 degrees. And they don't have to be, they don't have to share a common side. Okay, they could be let's say a 30-degree angle here in space, and a 60-degree angle here, not related to one another, just another angle we're referring to. Those would still be complementary because they still sum to 90 degrees. Okay, I think that covers all that we talked about in 3 and 4. Now I will give you the answers for 3 and 4 next. So go ahead and make sure you have your homework that you've already completed before you. Please make sure you do keep up with every lesson so that you don't have an overwhelming amount. If you cannot pass, I recognize we're studying at home and there's a lot more self-government on the student to be able to do this well. But if you cannot pass each chapter's test, then you cannot get credit for this quarter. So we are trying to give you credit so that you don't lose your school work this spring and have to retake it. But again, you have to be able to keep up with the material. Remember, as always, text me if you have specific or general questions about a section once you've tried to do the work. Okay, so I'm going to read them orally. You ready? If you don't have it, put it on pause, go get your homework, or if you haven't done it yet, put it on pause and do your homework, and then come back. Here we go. Number 1, 2 inches, next 1 inch, next 2 inches, next 2 3/4 inches, next 2 inches. This is measuring to the nearest inch and then measuring to the nearest quarter inch. Number 6, measuring to the nearest millimeter. You should have for number 6, 25 millimeters, next 40 millimeters, next 15 millimeters, next 20 millimeters. For number 10, your answer should be a ruler and a straight edge. Number 11, parallel lines. Number 12, perpendicular lines. Number 13, the symbol for parallel lines is this. Number 14, the symbol for perpendicular lines is this. Number 15, intersecting lines. Number 16, the number of straight lines that can be drawn through 2 points is 1. Number 17, the least number of line segments needed to form a polygon is 3. And number 18, the number of straight lines that can be drawn through 1 point is an infinite number of lines. So for number 18, your answer should be infinite. Okay, get ready here now for 8.4. Number 1, we're naming types of angles. Number 1 is straight, next right, next reflex, next obtuse, and next acute. Number 6, we're writing 3 names for each angle. Number 6 would be angle O, angle XOY, angle YOX. Number 7, angle S, angle RST, angle TSR. Number 8, angle Q, angle NQR, angle RQN. Number 9, angle B, angle ABC, angle angle ABC, and then the last one, angle CBA. Draw and label an example of each. Since we've already done the review and I had those on for 10 through 13, I'll let you look in the book. We've already reviewed that, or just refer to the review above. So number 14, okay, in book. So they just make sure you understand the definition of each of those types of angles. Okay, beginning now with number 14, write the number of degrees in the complements of the given angles. A complement means they must sum to 90 degrees. So my answer for 14 should be 67 degrees, 15, 45 degrees, 16, 34 degrees, 17, 30 degrees, and 18, 2 degrees. Beginning with number 19, we want to write the number of degrees in the supplements. Supplements have to sum to 180 degrees. So number 19 should be 50 degrees. Number 20, 166 degrees. Number 21, number 21 is 133 degrees. Number 22 is 10 degrees. And number 23 is 40 degrees. Beginning with number 24, the symbol for is congruent to should have a little squiggly line above an equal sign. Okay, is congruent to, which means what? The same size and shape. Okay. Number 25, write the sum of the number of degrees in supplementary angles. We just said that. Sums to 180 degrees. Write the name of the angle containing less than 90 degrees. For 26, the answer is acute. In the diagram, name the angle that is congruent to DOB. We're talking here in this diagram of 27, we're talking about opposing angles here. This is DOB, AC. So the angle DOB is this angle right there, and which one is equal to it? The angle that opposes it, right over here across from it. We call these vertical angles, so your answer should be angle AOC or angle COA. Could I just say angle O? No, because it's with these two lines, so all four of these would have that angle there, that angle there, that angle there, that angle there. All four of those would have a vertex of O. So angle O would not be sufficient for 27. You would have to say angle AOC or angle COA. Hopefully that is clear. Number 28, write the name of the angle containing more than 180 degrees but less than 360. And we've reviewed this idea a couple times already. That would be a reflex angle. Now the next thing we need to do is go ahead and give you your answers for the sharpening skills on 8.4. And they should be as follows. The sum of supplementary angles is 90 degrees. That would be false. They would, of course, would have to be 180. Number 2, 3 angles can be complementary. That is false. The definition of complementary is 2 angles that sum to 90 degrees. Number 3, that would be false. It says all polygons have 4 sides. No, polygons could have any number of sides from 3 and above. They just need straight sides. They need to be a simple closed curve with straight sides. Okay, so that means all my sides, I'm not going to have an angle. It's not going to be like this. That would not be a polygon. But this would be a polygon. That would be a polygon. Simple closed figure. Okay. So 3 would be false. 4 is true. A curve is anything where you can draw the whole thing. Even if it went like that, I could draw the whole thing without lifting my pencil. Number 5, a square is a type of quadrilateral. That is true. Number 6, a heptagon is a 6-sided polygon. That is false. A hexagon is 6-sided. A heptagon is 7-sided. Number 7, 2 angles with a common ray between them are vertical angles. Let's think about that. 2 angles with a common ray between them. Okay, there's an angle and there's an angle. Okay, it are vertical angles. Is that true? No. Okay, that's not vertical angles. Vertical angles are formed by intersecting lines taking the opposite angles. Those 2 are vertical angles. So number 7 is false. Number 8, 4 right angles are formed by 2 perpendicular lines. Okay, if I have 2 perpendicular lines here, there's line 1 and line 2, and they're perpendicular means, and this is how we symbolize it, this means this is 90 degrees. Well, if that one's 90 degrees, sorry, I'm struggling here with my pencil, 90 degrees, then this is 90 degrees, then this is 90 degrees, and this is 90 degrees. So that is true, number 8. Number 9 says, if these lines are all in the same plane and AB is parallel, so there's AB, is parallel to XY, and MN is perpendicular, there's MN, it's perpendicular to AB, what do I know about MN and XY? That they also are perpendicular. Okay. And so that's a true statement. You don't know how to prove that yet, and I'm not sure you will know how in this book, but that's a provable statement. Okay. So number 10, all right angles contain 90 degrees. That's true by definition. Number 11, a little more review. Your answer should be 25.74. And we would get that answer by it says 33%. So I would multiply 33% is 0.33 if I convert it to a decimal. And so we'd multiply 0.33 times 78. Okay. 1.5%. Okay. So 1% is 0.01. So 1.5% would be 0.015 times 120. And your answer should be 1.8. Now, another way to look at this, what is 1%? Do you understand your percents? Okay, let's look at the number 120. 10% is to lop off. So 10% of 120 is 12. 1%, there's 120 again, 1% would be to lop off 2. So 1% is 1.2. And if we had 1.5%, we would take half of that again. So add 0.6 to that. So if you're doing it in your head, this is sometimes the easiest way to do it. 1.5% then would be the addition of those two, or 1.8. Either way. So the answer is 1.8. Either way you do it. Number 13, 12 is what percent of 48? And the answer is 25. So I illustrated how to do that. Don't forget what percent means x over 100. Right? And then you cross multiply. Okay, number 14, 2,000. No, I'm sorry, 100,000 million. 2,021,334. Number 15, to add fractions or subtract, as we're doing in this case, you must have a common denominator first. Your common denominator will be 72, and your answer should be 1 and 70 seconds. Okay, 15. The answer is 1, 19 over 72. 16, to divide fractions means to multiply by the reciprocal, and your answer should be 3/2 or 1 1/2. And 17, you've got multiplication of fractions, but they're mixed numbers. And so you need to convert them to improper first and multiply. So let me do 17 for you just by way of review. 1 1/4 times 2 2/5. Please take advantage of canceling. You'll love it if you do. And the final answer is 3. Okay, so we're going to then upload this as part 1, and we will continue with part 2 in a different tape.